So a lot of people had a question about this one right here, which is given a water tank with G gallons initially being filled at the rate of F and emptied at the rate of E. Find the amount of water in the tank at M minutes. And I kind of want to break it as F is going to be the fill rate, E is going to be the empty rate. So we would obviously find the amount that's in there by doing the fill minus the empty, but those are amounts, right? We're given rates, we're not given the amounts. So to go from a rate to an amount, we have to take an antiderivative. So let's let A be our amount. So our amount at this time M, okay, is going to be given, we're going to take the antiderivative, right, of the fill minus the emptying, and that's going to get us from a rate to an amount. But where are we going from? We want to find A of M. We really have to think about it like this. Let me just do a quick aside here. Think about a position and velocity function for a second. If I'm given V of t, and I'm given S of 5, for example, and say they want me to find S of 20. How would I find that? Well, S of 20 is going to be equal to wherever I started, I'm given S of 5, plus the amount that I traveled between 5 and 20. 5 and 20. We're given V of t, we're given S of 5, so those are the only two pieces of information we can use to solve for S of 20. So in general, S of t is going to be, so in general, if we want to find this position, our final position, and we're given an initial position, so let's call that I for a second, initial position I, F is our final position, then we would start somewhere, S of I, plus, and then we go from I to our final position, what we're trying to find, of V of t dt, right? And just think about it this way, okay? So let me just start with concrete numbers. Evaluate the integral from 5 to 20 of V of t dt. That's going to be S of t evaluated from 5 to 20 because the antiderivative of V of t is S of t, which is S of 20 minus S of 5, right? So if I were asked to solve for S of 20, which I'm being asked to solve for in this case, you would add S of 5 to both sides. And we would get, so we have the integral plus S of 5 plus the integral is equal to S of 20. So that's how I do these problems in general. So let's apply that logic. Let's apply that same logic up here. So if I want to find M, and I'm given some initial, I'm going from 0 to M, then I must think about the amount at times 0 plus, because again, the integral from 0 to M of F minus E dt is going to be, well, the antiderivative of F minus E is just the amount that we have from 0 to M, which is A of M minus A of 0. So if I want to solve for A of M, I need to remember to scoot this A of 0 over to the other side. I need to consider where I started. And they told us in this problem that we have G gallons initially. And so that means that A of M is equal to G plus the integral from 0 to M of F minus E dt. And this is extremely important. Okay, so now that we have established that A of M equals G plus the integral from 0 to M of F minus E, let's go ahead and dig deeper into this question. Given the same initial information, find the rate the water amount is changing at time M. The rate at which the amount changing, so this is 73, is just A prime of M, okay? And A prime of M, the integral of G, which is the constant, is going to be 0. And then we're taking the derivative with respect to time of this integral. And the derivative of the antiderivative brings us back to the function itself, which is just F minus E, and our variable here is our M, right? That's our variable. So we're doing F of M minus E of M, and then when we put in the 0, that's a constant, so that's the derivative of a constant is going to be 0, so that just knocks itself out. And so this is just the fundamental theorem of calculus in action here. The derivative of the antiderivative is the function evaluated at that point M right there. And so we just have f of m minus e of m, and that is the rate that the water amount is changing at time m. So then in number 74 here, they're asking us the time when the water is at a minimum. So we have extrema when the derivative equals 0 or when the derivative does not exist. So pretty much if we know a prime of m is f of m minus e of m, then to find any mins or maxes, we would first find the critical points. In this one, we don't have anywhere that it does not exist in this general case here, so we just do f of m minus e of m equals 0, and then we find critical points. And then once you find the critical numbers, then you need to check all of them. So you need to check both the endpoints that you have. So you're going to find the amount at each of the endpoints. And then you need to compare that with the critical numbers that you found. So you're going to find the amount at each of those critical numbers that you found. And then again, to find the amount, you would just use this equation right up here. And if you had your calculator, make sure that you're using Fill&Empty to quickly solve that. And yeah, that's about it. You would then find the absolute minimum value in this case. And if they were asking you for the time at which it was a minimum, you just need to find the time, but you need to compare all the values. So those values to see which one is the absolute smallest one, and then you would choose that time as your final answer. So that's it. So the other question that was asked a fair number of times is the difference between the average rate of change and the average value. So the average rate of change is just your algebra 2 brain, so that's your slope. So that would be f of b minus f of a all over b minus a. In other words, y2 minus y1 over x2 minus x1, versus the average value, which if you're given some function f, then you would do 1 over b minus a integral from a to b of f of x dx. Now, I think where possibly people are getting confused is in an example problem that might be find the average velocity of a particle on AB. So it depends on what information you're given. Average velocity, if you're given the velocity, then you want to find the average value of that function. So you need to use this formula here. If you're given velocity and you want to find average velocity, right, then you would do 1 over b minus a integral from a to b of v of t dt. And think about units. If you want average velocity, what are the units going to be? They're going to be something like meters per second. What is this units here? The integral of velocity would be a position thing, so the units here would be meters. And 1 over b minus a, well, b minus a, b and a are times, so you're dividing by seconds. So the final answer would be meters per second. So that makes sense. Now, there's an alternative way to solve this average velocity question if you're given information about the position function. So if you're given information about the velocity and you want to find the average velocity, then you want to find the average value of that function. But if you're given the position function, then to find the average velocity, you have to think a bit. What's the relationship between position and velocity? Well, you know velocity is the derivative of position. So the average velocity would simply be the slope of that position function. And think about it, s of b minus s of a, those units are going to be in meters because that's position function, and dividing it by b minus a, and that's going to be a time. So you're going to get back to a meters per second type of thing. So that's going to give you the right units. After all, aren't they equivalent? Right? Look at it here. Let's start with this here. 1 over b minus a integral from a to b of v of t dt. And that is going to be, let's leave that 1 over b minus a on the outside. And then the antiderivative of velocity is giving you the position function. Evaluate between a and b. So you get s of b minus s of a divided by b minus a. S of b minus s of a all over b minus a. So these two things are equivalent. To find the average velocity, it depends on if you're given the velocity function, you do this. If you're given the position function to start, you do this. So you just really have to think about the information you're given and what you want to find. And when I'm lost and confused, I think about what units I want my final answer to be. Average velocity, I clearly want my final answer to be in meters per second or whatever units I'm given, right? So I just look at whatever method I'm choosing and make sure that the units match up, and I usually get the right answer. So I hope that helps.